The use of cleaner hydrogen in these industries would be extremely beneficial. A multi-institutional team led by the U.S. Department of Energy's DOE Argonne National Laboratory has developed a low-cost catalyst for a process that yields clean hydrogen from water. Other contributors include DOE's Sandia National Laboratories and Lawrence Berkeley National Laboratory, as well as Geiner Inc. A process called electrolysis produces hydrogen and oxygen from water and has been around for more than a century, said Dejia Liu, senior chemist at Argonne. The reduced energy demand makes them an ideal choice for producing clean hydrogen by using renewable but intermittent sources, such as solar and wind. This electrolyzer runs with separate catalysts for each of its electrodes, cathode and anode. The cathode catalyst yields hydrogen, while the anode catalyst forms oxygen. We sought to develop a low-cost anode catalyst in a PEM electrolyzer that generates hydrogen at high throughput while consuming minimal energy, Liu said. By using the cobalt-based catalyst prepared by our method, one could remove the main bottleneck of cost to producing clean hydrogen in an electrolyzer. Geiner Inc., a leading research and development company working toward the commercialization of electrolyzers and fuel cells, evaluated the new catalyst using its PEM electrolyzer test stations under industrial operating conditions. The team deciphered critical structural changes that occur in the catalyst under operating conditions by using X-ray analyses at the Advanced Photon Source (APS) at Argonne. The APS and CNM are both DOE Office of Science user facilities. We imaged the atomic structure on the surface of the new catalyst at various stages of preparation, said Jianguo Wen, an Argonne materials scientist. In addition, computational modeling at Berkeley Lab revealed important insights into the catalyst's durability under reaction conditions. The team's achievement is a step forward in DOE's Hydrogen Energy Earthshot initiative, which mimics the U.S. space program's Moonshot of the 1960s. Applications include the electric grid, manufacturing, transportation, and residential and commercial heating. More generally, our results establish a promising path forward in replacing catalysts made from expensive precious metals with elements that are much less expensive and more abundant, Liu noted.